My name's Matt Newport. I'm the owner and chief engineer, I guess, at Black Lion Audio. We modify audio equipment, primarily digital audio interfaces. We do manufacture some equipment of our own. I've worked in RF, which is radio frequency manufacturing. I've worked for companies that manufacture airport navigation systems, and then I've also done quite a bit of time in recording studios as well. I actually started working on a project with a couple of friends as the audio engineer. And the problem that we had with this project was that we didn't have a lot of budget, which I think most people can relate to. And given my background in electronics, I decided that I would take it upon myself to see what I could do with the little budget that we had. Initially, I think what I had done was I decided, well, I'm going to buy one of these little tube mic preamps that this company called Paya manufactures. They're based out of Oklahoma, and they sell kits. And I bought one of these things for like $30 on eBay, and I went through every aspect of the circuit and modified it for our project. And then I actually wrote an article about it for Tape Op magazine, although I don't think it was ever published. I don't know, it might have appeared on Pro Sound Web or something like that. It's out there somewhere. And so that was kind of the start of it. And I realized, like, hey, there's, you know, a lot of opportunity here. And given my experience with RF level stuff, and digital audio is very similar to RF level in that you have a lot of high frequencies, like hypersonic frequencies that you have to deal with. So I decided to delve into the digital aspect of things. And I think the first digital piece that I ever really worked with was one of those Roland VS platform things. And I just didn't like the mic preamps in them. And so I decided I would go through and see what I could do. And that we were pretty impressed with the end result when we finished tracking. We were surprised at how just dealing with analog sections alone helped improve signal quality, made it easier to get a good sound going in, made it easier to mix down, helped us to make better choices when it came to mix down, and ultimately helped our budget go further. When working in that sort of like a production or airport navigation systems environment, the federal government gets involved in that, and they want to make sure that you not only know what you're doing, but you know processes that are considered to be important to manufacturing and long-term quality. And we call that ISO 9000. It's a type of certification. So they require you to take a course. Yeah, just the knowledge learned from that, from the production side of things in that environment. And then the sorts of things that you pick up working in a production environment like that, it's kind of funny when you get into audio. Things are a little more rigid in a weird way, but also a little less rigid. Like they're a lot less refined. For example, the things that I learned as far as clock signal quality, I have yet to come across anyone in the world of audio that even approaches it from this perspective. The way that we understand jitter, the way that we understand propagation of signals throughout a digital system is it's almost I don't want to say rudimentary because I don't want to insult anybody, but it's a lot more simplified. A background that requires so much more precision definitely translates into audio. And one of the things that I like to try to explain to everyone about signal propagation within digital audio, we like to think of it as like a set of ones and zeros that just, you know, it's either on or it's off, and that's all it is. But in reality, these signals are actually analog signals. They're square waves. They have harmonics. And if the phase of those harmonics shifts, or if the amplitude accidentally gets increased by just a hair, it will affect the resulting signal, the converted signal. So the way that we try to approach what we do with these existing units is we try to ensure, I guess, signal quality within the digital realm. And then the end result, of course, on the analog side is that you get a lot better signal quality. So.